So picture this. There's a developer. Let's call him Timothy. He's working on a pretty cool chess club app, and he's just come up with what he thinks is a genius idea for a new feature.
His plan sounds totally solid, right? The app logs every single move to a text file. And for those what-if moments, he wants a brand new, separate log. So he thinks, easy, I'll just deep copy the logger object. It feels clean, it feels elegant, and it's about to blow up in his face.
And there it is, a big, ugly type error. Suddenly, all that confidence is gone. What in the world is an _io.textio wrapper? And why can't Python's super powerful deep copy function touch it? Well, that cryptic message, that's our key to understanding everything.
See, what Timothy just hit wasn't really a bug in his code. He ran headfirst into the ghost in the machine, this invisible but very real wall that separates the neat and tidy world inside his program from the messy physical world of the computer itself.
This really breaks it down. Think about it as two separate worlds. On one side, you've got Python's private little universe. This is its memory, where all your lists, dictionaries, and custom objects live. Python owns this place, and it can copy and clone anything it wants in here. But then, there's the other side, the outside world. This is where files, network sockets, and database connections live. And here's the catch. Python doesn't own these things. It just gets temporary permission from the operating system to borrow them.
Let's use an analogy. A file is like a library book. Simple enough. You can take that book and photocopy every single page. That's the data. No problem there. But the thing that lets you access the book in the first place, your library card, well, that's the file connection. It's a unique permission slip from the librarian, the operating system. And you can't just photocopy your library card and hand it to a friend. It won't work. They have to go get their own permission.
And this isn't just Python being difficult. There's a really good reason it stops you from cloning these library cards. It's to prevent you from accidentally causing a complete and utter disaster.
But let's just imagine for a second. What if Python just let you do it? What if you could clone that live file connection? What kind of chaos are we even talking about here?
It would be an absolute mess. It's like giving two people the same notebook and telling them to write on the exact same line at the exact same time. Your original logger is trying to write white to E4, while your clone, at the same millisecond, is trying to scribble black to C5 right on top of it. The result? Total gibberish. Your log file becomes corrupted, unreadable garbage. The operating system sees this coming a mile away, and to protect the file, it just pulls the plug, crashing your program or throwing that error Timothy saw.
So, if you can't clone the live connection, what are you supposed to do? Well, the answer is surprisingly elegant. You don't clone the permission slip itself. You clone the idea of getting one.
So let's look at this side by side. On the left, you've got the wrong way, trying to copy the logger object that's already holding an open connection to a file. But over on the right, that's the smart move. You create a new logger, and you just give it the information it needs to go get its own separate connection.
To put it simply, you don't give the new object your library card. You just tell it the name of the book, matchlog.txt. That way, it can walk up to the librarian itself and get its own card. You copy the configuration, not the live connection.
This entire lesson, this whole headache Timothy went through, it can really be boiled down into one simple, incredibly powerful principle that will save you so much trouble down the line.
We're calling it the Guardian Rule. Think of it as a promise you make as a developer. You promise to be a responsible guardian of these resources the operating system is lending you. You open them carefully, you make sure no one messes with them while they're in use, and you always ensure they are properly closed when you're done. And of course, you never, ever try to clone them. All right, here's your cheat sheet to lock this in. Internal stuff like lists and dictionaries, Python owns them, you can clone them. External stuff like files and sockets, the OS owns them, you can't. If you see that type error talking about an under IO object, ding, 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 you've hit that boundary. And the solution every time is to copy the configuration, like the file name, not the live connection itself. And for those of you who want to get fancy, you can actually customize the special _deep copy method on your own objects to teach them the right way to be cloned.
Now, trying to follow the Guardian Rule manually all the time can be a bit tricky, and that's exactly why Python gives us more powerful professional tools for the job. This whole idea is the gateway to understanding things like context managers with their _enter and _exit methods. That's how the pros build objects that are automatically safe and disciplined guardians of these outside resources.
So in the end, what Timothy learned wasn't just some quick technical fix. It was a real step up in his craft. You know, it's one thing to know how to manage the data inside your object. You could call that its soul. But the real mark of an experienced developer is learning how to responsibly manage the things it borrows from the outside world, its possessions.